Ladies and gentlemen, please put your hands together and welcome on stage our esteemed speakers for this session. Please welcome Shri Nitin Khanna, Managing Director, Energy Accenture in India. He is the moderator for this session. Please welcome him with a huge round of applause. With over 16 years of experience in driving strategy and transformation initiatives within the oil and gas industry, he has worked extensively across the entire value chain from upstream to downstream, assisting clients in addressing their strategic and operational challenges. Nitin has significant experience in areas such as refining, fuel retailing, lubricants, and petrochemical sales. So please give him a round of applause and welcome Nitin Khanna on stage. Joining him on stage are Dr. R.K. Malhotra, President, Hydrogen Association of India. Please give a round of applause to Dr. Malhotra and welcome our speakers on stage. Please welcome Mr. Rajat Sekasaria, CEO, Green Hydrogen at Adani New Industries. Please welcome Shri Hiren Mehta, Chief Commercial Officer, Acme Group. And please welcome Mr. Som Shantanu, Asia Engineering Lead, Gas Power GE Vernova. Please give a round of applause to all our speakers. Coming up on stage, we have Shri Nitin Khanna, Dr. R.K. Malhotra, Mr. Rajat Sekasaria, Shri Hiren Mehta, and Mr. Som Shantanu, who will be discussing this very important topic of hydrogen energy. I'll hand it over to Nitin to steer the discussion.
Good morning, ladies and gentlemen, dignitaries, leaders, and experts on the panel. Welcome to this inaugural leadership panel discussion of this year's PowerGen India Conference and the India Utility Week. The agenda of the panel discussion today is to discuss the pivotal role of hydrogen, rather green hydrogen, in helping India navigate its energy transition ambition as well as become self-sufficient in its energy needs. The discussion will focus on both strategic and operational aspects from demand as well as supply side of how do we make hydrogen, rather green hydrogen, a reality in the coming years. And to do so, I have a distinguished set of panelists from the industry and the broader ecosystem to share their perspectives on the topic. The way we'll go about this is, I think we are definitely missing a couple of original planned panelists, the Honorable Joint Secretary from MNRE and MOPNG. So we'll just change slightly the sequence a bit. We'll keep it across two rounds. The first round will focus on some of the topical, pointers on the green hydrogen industry. And then in round two, we'll delve deeper into some of the specific aspects of it. And I think I'll request each of the panelists to sort of, keep their comments roughly around 5 minutes or so that we can give adequate time for each of the panelists to share their perspective. So without further ado, what I'll do is try to level set the discussion today by sharing some perspectives, certain statistics, certain projections in the years to come, so that as we start this 3-day conference, we're all talking in the right context. So, just to get started and, set the stage, India is a large and a growing, energy market, which has implications for not just the domestic, market, but also for the globe. Over the last 20 years, as the economy has grown, India's energy demand has, grown by about 2.5 times. The good news is, in the same period, the share of renewables in the India energy demand or the India energy mix, that has also grown. But unfortunately, despite the multifold growth, you know, two-thirds of India's primary energy demand continues to be driven by fossil fuels. So that's the last 20 years, some numbers around that. If we fast forward to the next 20, you know, we are slated to grow anywhere in the range of 6 to 7%. That will mean we will triple or quadruple our GDP over the next 20 years, and that growth will put tremendous demands on energy. Please remember, growth is energy hungry, and therefore, what we import today is about 180, 200 billion dollar of fossil fuels. So that demand is going to grow, and the reason to put that on the table is for all of us to appreciate that the scale and the enormity of the challenge that we are talking about as we discuss the energy transition opportunity. Within that, green hydrogen is seemingly very, very exciting for two reasons. One is, it offers an opportunity to decarbonize certain select use cases, and I'm sure the panelists will talk about it, as well as it gives us hope to become self-sufficient in our energy needs because, hydrogen, so to speak, fundamentally is available in plenty. So, why import? So that's the opportunity that is there, in front of us, and that's the reason we have all gathered here. And of course, from a power sector perspective, it's a market. The green hydrogen economy is a market because you'll need, renewable energy, so on and so forth. There are some interesting, ammonia plays that we will talk about for power generation itself, which is a bit far-fetched, but an opportunity, for all of us to consider. So, with that, I also want to just touch upon the government of India had signaled and shown the right intent. We launched the National Green Hydrogen Mission back in January 2023. I'm sure all of you are aware of it, but to very quickly put it in context, we are talking about 5 million metric ton of green hydrogen capacity by 2030. That itself will, translate into sizable investments on the renewable energy generation, which is, to the tunes of about, 80 to 100 gigawatts, or rather more, about 125 gigawatts, about 80 to 100 gigawatts on the electrolyzer capacity. It will require about $100 billion, of potential investment, and has the potential to create about 600,000 jobs, the right skilled jobs for the country. So, and that's the broad sort of pretext to the discussion. So the government has signaled the intent. Alongside, I think the industry stakeholders have followed suit, both from the private as well as the public sector enterprises. And there have been announcements across the board, which are largely to test the waters. These have been pilots at certain scale to see, how do we stand, and how does this stack up compared to the alternatives that exist. So, with that being the broader context for the discussion, I'll go to my first panelist, Dr. R.K. Malhotra, and the question is, fundamentally this, Mr. Malhotra. Um, Hydrogen is not new. Hydrogen is not new, right? We have the demand in terms of gray hydrogen. We have the renewables. We have the electrolyzers. It's an age-old technology. Given the intent signaled about 1.5 years back, where do you see we have arrived or will arrive by the end of this year, when about 24 months of time has passed. Um, how has the on-ground progress been vis-a-vis some of the plans, commitments, from various participants, constituents of the industry?
Thank you, Nitin, for the introduction about the subject of this discussion today. The current status of this green hydrogen mission, which was announced in January last year, has been significant progress. I must say that has been made from the government side. I am also a member of the expert group on green hydrogen mission, which is chaired by the Cabinet Secretary, and every 3 months, Cabinet Secretary has been reviewing the progress of the green hydrogen mission activities. And I must say that from the government side, the government has been doing its bit, and very serious actions have been taken in terms of site scheme, etc., where they are incentivizing. They have announced incentives for electrolyzer manufacturing, PLI, etc., and also in terms of the subsidy for green hydrogen production. The government is also committed to support the green ammonia production and creating the infrastructure for export and providing all kind of incentives. In fact, the earlier Power Minister, Mr. R.K. Singh, I heard him saying very clearly that the government will go out of the way to support the export also, because there were some issues where people were saying that there are concerns about if the industry produce green hydrogen, who will take it? But on that side, I must say that there have been a lot of talk about, the creation of facilities and those kind of things. But the technology part of it, the electrolyzer technology, and I personally see that the electrolyzer manufacturing, where the technology has to come from overseas, is taking time. And the electrolyzer manufacturing and electrolyzer capacity could become, one of the challenge. But I'm sure the industry is responding very well. In one of the meetings, the Secretary MNRE was asked that we have a target of 5 million tons, and how about that, whether we will be able to meet it or not. It was informed by MNRE that the commitments are already there from industry for about over 7 million tons by 2030. So it's satisfying that even if 7 million tons commitment is there, so surely our 5 million tons target would be met. We hope that this side of technology, availability, electrolyzer manufacturing capacity, green hydrogen production, etc. One of the also is that green hydrogen coming from biomass. We have large potential, and that hydrogen is cheap. The biggest challenge is about the cost of hydrogen, green hydrogen, which is because I come from the oil sector background, where we produce large quantities of hydrogen in our refineries from natural gas, and it costs us about $1.5 or so per kg, while the green hydrogen is anywhere between $4 to $5, as people say, and it hopefully with the electrolyzer increased capacity and lower cost and capacity induction, etc., this may come down. But I don't foresee that it will come down to $1 per kg, which was envisaged and announced in 1 decade by one of the private sector player. Even if it is $2, I think that would be very, very attractive, and there would be many people. I know from the oil industry side, they say that if green hydrogen can be made available to us at $2 or $2.5 a kg, they would be very, very happy to increase. And the government side, they are also coming out with the carbon emission trading system, where some of the obligations will be there on part of some of the industries that they have to decarbonize, as you said, decarbonization. So, of course, the demand for hydrogen will also increase, and people would be willing, if they get carbon credits, they would be willing to pay more for green hydrogen. So I see a lot of opportunities, a lot of R&D support is also being given, a lot of R&D schemes have been announced where incentives for R&D activities are also being given, so that we have our domestic Atmanirbharta in this field. Renewable energy is growing very fast. The costs, we saw that coming down from 16, 17 rupees to 2 rupees per unit of power. So hopefully the same thing will happen in terms of the electrolyzers, but there is a limit that up to which it can come down, and the cost of electricity is already perhaps bottomed out. So you need about 50 to 55 kilowatt of electricity and 9 liters of demineralized water. So these are the basic inputs which will have some cost, and then the depreciation and operation and maintenance cost of electrolyzers, etc., will have to be added. So I personally feel that with all the kind of support which government is offering, even if we get around $2 to $2.5 a kg or something between $2 to $3 a kg, that would make it. And government is committed to support, and I think that support has been very, very well coming.
Okay. And if I can just, since you've been in the oil industry, Dr. Malhotra, I'll just ask an associated question, which is, do you think the scale of the pilots and the effort being undertaken and the collaboration across the OMCs, particularly the refiners as well as the fertilizer companies, do you think the scale of pilots is adequate today to demonstrate the what's the maximum that we can stretch the cost curves to showcase the competitiveness with respect to the gray hydrogen, which is about $1.5–2? Or do you think there is more to be done? And the reason I ask this is, I think we all know a lot about green hydrogen. I want to make it really provoking, so that it's worth everyone's time here today. What's your reflection on the effort and the scale of pilots being undertaken across the refiners and the fertilizers companies?
Many of the public sector refiners are already going for some of the projects amongst themselves. They are setting up their own projects for producing green hydrogen, because there has been talk about obligating the refineries to use certain percentage of the hydrogen input, replacing the fossil fuel based hydrogen by green hydrogen. In a gradual manner, that percentage is supposed to be increased over the years. So they are preparing themselves. They are themselves going for some of the tenders for call for proposals, which you would have seen. Of course, in some cases there have been some delays, but some of them are progressing very well. Like some of the, I don't want to name any particular refiner where the problems have been there or which have progressed. But another thing which is also they are looking at is you have bio-compressed gas units, also BCG units, where under Satat scheme a lot of units are coming up. So many of those are also thinking that from this bio-compressed gas, they know how to, natural gas reforming they've been doing to produce hydrogen. So if the bio-compressed gas is also reformed, and then they can get green hydrogen. So that would also be a low-cost hydrogen available to them, which will compensate for the electrolyzer-based hydrogen to some extent. So they are going for both. So I'm sure on the fertilizer side is a little bit challenging, because the fertilizer industry cannot, this already getting subsidy from the government. And if they go for green hydrogen, which will be even more expensive, then they will look forward to more subsidy from the government. So whether you give subsidy for green hydrogen production or electrolyzers, manufacturing, etc., or you give for fertilizers, I think that's a trade-off. The government has to move very cautiously on those. These issues have also been discussed in the cabinet secretary meeting, that how we should proceed on those, and that fertilizer people have been saying that they can't afford to increase the cost, and as we know that there are several issues connected with the agriculture sector, fertilizer cost, etc.
Sure. Thank you, Mr. Malhotra. I'll come to Rajat next. Rajat, we heard Dr. Malhotra.
Sorry?
Yes, your mic is working, we can hear. So we heard Dr. Malhotra's comments. You represent one of the largest, conglomerates and their aspiration in the hydrogen space. We also hear, the perspective from the first order consumers for green hydrogen, right? That it's the cost curves across the renewable energy generation as well as the electrolyzer cost. Today the $0.50 kind of a subsidy is not adequate to make it, cost competitive. So how do you see the green hydrogen opportunity in the domestic market, A, and B, there's also significant, foundational advantages we have to become a potential export hub for hydrogen. Would love to hear your perspectives on both of these, Raj.
Thanks, thanks for the question and thanks for inviting me for this forum. So first of all, let me give the perspective that, as you say, is one of the large players has on the sector. How are we approaching the sector in general? So at Adani, our approach to the sector is very, very clear. For us, it is about an energy project which you need to provide reliably, scalably, and in a cost-effective manner. So how do you do that? So our approach is very clear. We need to have complete control over the supply chain. And the supply chain for us starts from the onset of having land for generating hydrogen in quantum we are looking at. So first of all, have enough large-scale, good renewable potential land in your control. Don't rely that something will happen, government will give land or something will happen. So that is what we have been doing for last 4 years, aggregating land which has very, very good renewable potential for generating hydrogen eventually. So we already have land for equivalent of 2 million tons of hydrogen, roughly 85 to 90,000 hectares of land which we are developing, which are dedicated only for hydrogen. Secondly, you need to have control over transmission of power. Fortunately, as Adani Group, we are also the largest private sector transmission company. So we technically are in that sector, understand that. When you're generating renewable power, you need to have control over capital equipments that go into renewable power. We are also the largest module manufacturer. We are also manufacturer of largest wind turbine in the country. So we control that ecosystem in toto. Right now, the next element is electrolyzer. Our teams are working on electrolyzers. The factory of electrolyzer is under works. We are expecting that to be up and running in next 2 years' time. So then electrolyzer is also something which we have. Once you have hydrogen, potentially you convert that into a derivative like methanol or ammonia, where we can license technology. And to ship it out, you need ports. So Adani is one of the largest port developers in the country. We have access and control over most of the ports in India. So our approach to developing this sector is having complete control over the supply chain, because otherwise we are exposed to what is called project on project risk, which then reflects in not only the project risk but also in the cost that will add up in the value chain. So that is one approach we have. Secondly, once you have the ability to deliver project at scale that we are developing for ourselves, what markets do you treat? For us, the large scale market for hydrogen will initially be in this decade, would be outside of India, for those countries and those sectors which have some mandates directly, indirectly built into their working. Japan, for example, we know they have indirectly built-in mandates for converting some of their power to co-firing. Europe, for example, we know they have an RFBNO compliance requirement till 2030. So these are markets where they have mandates, they have a faster net zero program, and because of that, they also have a better affordability or paying capacity for these green products. So we are specifically targeting these markets, and the USP we have at Adani is our ability to supply. So we are not vouching to be the lowest cost supplier, but we are certainly in a cost effective manner the most reliable supplier of our green electrons outside India is how we are positioning ourselves because of the overall supply chain we have built. Third point about the domestic market, I think the way domestic market is evolving is something which we saw in renewables 15 years back. You have small incremental efforts. That's what government is doing here. To be honest, the price of hydrogen today is still at an elevated level. So we are talking about potentially $3, $2.5, $3, which would still mean significant cost disadvantage compared to incumbent sectors. So what government has started in terms of building some areas of demand, I think will be something which will help the industry to give us some initial projects. And once this becomes a demonstrated concept, then we can have projects at larger scale. So we don't think the bulk of our project will be based on Indian demand. Our bulk will be based on export demand, where the paying capacity is higher. But I think the key there is ability to reliably supply. We need to remember this is an energy product, right? And only those players who can reliably supply, not only having the supply chain, but having the ability to finance this multi-billion-dollar project, ability to integrate multiple technologies, ability to use in-house skills which are there. I think those will become the USPs, which will be a differentiator, not only for developers out of India, any developer globally. And I think that is where the real opportunity Indian developers have.
Perfect. Appreciate those comments, Rajat. I think you made three very crucial points. One is, you're taking an integrated play, both backward and forward, across the value chain, so that you have full control and can emerge as a reliable supplier of green hydrogen. Second, you make a very important point for us to break through a lot of noise and euphoria that, the opportunity is real. But the way things stand today, the exports market may take precedence to build a commercial viable business versus the domestic market. So there's a sequencing that we are talking about. And if we get some of these two right, there's a potential to build a scalable, profitable, and sustainable business, out of this very versatile molecule that we are discussing. I want to extend that, thoughts and bring in Hiren. Hiren, you represent one of the private operators. Of course, I want to understand your perspective on how you're viewing the hydrogen potential at your firm. But specifically, if you can bring to life, we have seen the success of solar and wind. I think if we roll back the years, 10 years back, we would have been discussing roughly the same things on solar. 15, 16 rupees, tariff, which are now down to about 1.5, 2 rupees. So one, your overall perspectives, but two, what are some of those learnings that we can take from the massive growth success story that you have ridden on the solar and, wind renewable side that we can apply to green hydrogen, and possibly a little more, on both on the demand. How do we spur that? Your thoughts, Hiren?
Yeah, thank you, Nitin and Pawajan, for this opportunity. So let me just address your first point. That cost of renewable power has came down significantly, more than 80% in last 10 to 12 years. So the way it has happened and the factors which has made this happen are three major factors. If you see that the cost of solar PV module has came down significantly, more than 80% again, along with the balancer system. Second thing is the innovations, like, as an example that micro inverter has also played a very significant role in the reducing the cost. And the third very important aspect, specifically for India, that SECI playing the pivotal role, they have ease out sales and purchase of the renewable power in our country. So this is the three major reason why the cost of power has came down and the adoption has become possible in India. So if we draw parallel this to hydrogen, and hydrogen industry today are actually relying on this success very heavily. So in the hydrogen and ammonia, if I put together, then solar PV module, as I said, it's a mature technology anyways, and established supply chain. Of course, not in our country yet, but in globally. So there is not much expected to come down in the price. Second, very important for the green hydrogen is electrolysis. So that I'll address later. But if you produce a green ammonia beyond hydrogen, then it's a hybrid burst process, which is 150 years old technology, and hence not much expected in terms of technology development there as well. Now, if you look at the electrolysis, which is the heart of the green hydrogen, and where currently, there are not much production capacities available in the world, and even if you look at the electrolysis efficiencies, 60%. So this is the area where there are a lot of things are expected. What happened from in the power or renewable power sector in the solar PV module, that efficiency will grow up, having the more production capacity of the electrolyzer, economy scale will play, and both will bring down the cost, and technology innovation also will play a significant role in that sector. So all three together, and very importantly, the supply chain. Like, we've seen that in China, the way the supply chain is developed for the solar PV module, similar thing which is also expected to happen in India, which Rajesh has mentioned, to have the complete control from the manufacturing the solar PV module, complete project to deliver the green hydrogen. So yeah, I mean, it's a similar story which is expected, and electrolysis and electrolyzers will remain the center in terms of the technology, and they bring the cost down.
Okay, and Hiren, if I can just ask your perspectives on the market potential, domestic versus exports.
Let me just paint a macro level picture that hypothetically, if you were to replace the entire energy consumption which is happening from oil and gas, coal, and the natural gas, so somewhere more than 900 million ton per annum of green hydrogen would be required, which is very, very high. Even if you take only the hydrogen production, currently must be around 100 million ton globally, and in next 8 to 10 years is expected to go double, almost 200 million ton. Even if that has to be taken, only 10% or 15% of that comes around 20 million ton to 30 million ton, and that's a significant demand as we see today. Largely, this demand will come from the export market for India. Those countries increasingly bringing the incentives through the policies, and I mean, this known to us that Europe, Japan, and the Korea are the market whom would be taking a lead for the consumption of the green hydrogen and ammonia. And of course, we are also, as a company, we are also keeping a track on the our domestic market. SECI has came out with the green ammonia tender, and some of the refineries also has shown interest to have the on-site green hydrogen production. So going forward, of course, the export market will develop first, and domestic market over a period of time will see that there will be consumption of the green hydrogen.
Thank you, Hiren. Appreciate those comments. I think it's crucial to have the pace of technology innovation, technology development to make the economics and the cost curves, become comparable to the alternatives. I think that's key, as well as the supply chain points that you make. And that's the right segue, Som, for you to come in, share your thoughts with us. As someone who's part of the ecosystem from a solution provider perspective, I have two questions, and I'm sort of trying to juggle around the questions because we have 2-3 misses on the panel. I think one is, of course, how do you see the role of green hydrogen, and how is GE Vernova sort of embracing that and getting prepared for that. But I also want to come to you with a little bit of a curveball, which is it's not an hydrogen opportunity. We say sometimes it's an ammonia opportunity. And can it be used as a storage solution to balance the grid, or as a power generation solution itself, so becomes an energy source in itself. So your perspectives on these two aspects would be very helpful.
Okay. Nitish, first of all, thank you for having me here. I'll try to do justice to the questions you have. First of all, as a power professional, I think I'm fortunate to be in a time and a space where two massive transitions are happening. Number one, the industry is growing. With data centers coming in, AI become reality, EVs are everyday thing. There's a massive demand on power. Plus, there's about 700 plus million people across the globe who don't have power. On the flip side, you got the responsibility to decarbonize the industry. If you take China and India out of equation, still 800 gigawatt of coal is on grid today, right? And it's not going to be cheap to retire coal. You're talking of $4 trillion of kind of investment. So when you look at these two, the market is reacting to this in a different way. The way I see it, globally, in Asia, in South Asia, there is a trend where as the capacity increases, doubles up, for example, in South Asia, there's a massive growth in renewable. Solar is going 4.5 times in the next decade plus. Probably wind is going 3 times the current investment, right? So as the massive growth in renewables is happening, we also see that gas, hydro, nuclear, they're flat. Coal is growing. Coal is already 49% in India. It's still growing, right? Now, with that perspective, let's step back a little bit. Let's talk a little on this topic from a different angle. I want to bring in the grid stability piece on board, right? As you talk of renewables, one of the biggest challenges we have with renewables is they don't have rotating inertia. They're intermittent. The storage capacity is not to the point where we expected it to be. There's still 6-8 hours kind of capacity today on batteries, right? The other piece is they do not generate reactive power. And should there be a grid oscillation, they react very differently from a conventional rotational inertia kind of machines. So if you will, for example, if your car has a shock absorber, renewables become stiffer and weaker from a shock absorber perspective. Now here's the point. With such a massive growth in renewable happening, how much is really deployable? When you ask that question, and we have been doing that across the board, we have been talking to different, as GE Vernova, we have gone to different grid operators and have started talking about this. We do realize that people have started doing their own system study to really understand, and I know South Asia has done that too, as to how much is really deployable. You understand that probably 24-25% is realistically deployable on the grid. But your expansion is going to be way beyond that. What do you do with that? That's where I think the green hydrogen concept comes in, where the excess renewable, can I use it for green hydrogen production? Can my gas turbines absorb that? Now, why I pick gas turbines is, as renewables are intermittent, you need the shock absorbers to ramp down fast. They need to go to a pretty low load where they're still compliant with the emission. Gas turbine and hydro can do that. Coal struggles, nuclear struggles, right? So when you look at gas and hydro, how this excess renewable can feed into a green equation to produce hydrogen? Comes the question of economics then, right? Actually, 2 questions. How affordable, sustainable it is, and can your gas turbines really do it? Well, and when I go back to gas turbines, the oil and gas industry has taught us how to use hydrogen. They had 2 options, either flare it or burn it, right? So they started burning it, and they pulled us as OEM saying, can you really burn it? We have slowly developed our capability on that. There are gas turbines, around 120 of them, which are operating on certain blends of hydrogen in oil and gas industry. When you come to the power gen industry, it becomes a little bit tricky given the volume of hydrogen you need, right? So that's one point. The other point I want to bring in is there are examples across the globe, and I want to bring this example from US. There's a plant called Debari. These plants had 7E gas turbines, pretty small gas turbines. They had operated on oil, but it became uneconomical for them to operate on oil. So the option was they slowly moved to solar. And they have a 74 gigawatt of solar panel installation on the site. They started using solar to pump to the grid. Come to a point where the grid said, no more solar, you have too much, right? So they can only dispatch 30% of the solar they have installed. The rest, they had to find an innovative solution. They started putting electrolyzer right at the site, producing hydrogen, The 7Es are consuming 100% hydrogen since 2024, right? Earlier this year. Now, I want to bring this example because these are those solution-based examples where you bring in the hydrogen production and the consumption closer, eliminating the storage, transportation equation out. And that's the major chunk of the cost, right? So I thought I'll tee that up because I think this flows in well to the challenges that you are talking about, right?
Thanks, Som. And I also want to ask a small follow-up question. It's a very brief response. What's the timeline for this to mature and become competitive?
So gas turbines are ready today. And we have done pilots where we can burn up to 50% on a very high efficient machine. H-class is a very high efficient machine today for us. So it's hydrogen ready. It's a question of affordable and sustainable hydrogen supply. The beauty is gas turbine is agnostic to the color of hydrogen. It doesn't care, right? So which is where if you think about oil and gas, SMR, CCUS combination, a blue hydrogen still works. End of the day, you're trying to get a greener version of the hydrogen, right? So I think I'll leave that.
Okay. Thank you, Som. We have about 10-12 minutes at max. I'm just looking for some signal from the sponsors and the organizers as well, whether we have more time. But I want to go to our next round, which I said, our attempt is to make it a little more, thought-provoking. And the first question is to you, Dr. Malhotra, on the round 2. We heard the opportunity is more export, less domestic. The ask is, how do we spur the domestic demand? So very specific, out of the box, what we can do to spur the domestic demand, because, the current, support is great, but not enough is what we hear. So what out of the box we can do, especially on the demand side of it?
Sure. The demand side situation is that, as everybody has been talking, that there is no offtake, guarantees, etc. So I think some of the obligations on some of the industry which uses hydrogen, if obligations are put by the government, I think that will assure the producers to ramp up their production capacities. That's number one. And some of the stable policies. And then, one more thing is that I have been, looking at the data, that the hydrogen demand in this country at present by the refiners or fertilizers or other sectors is about 7 million tons. By 2030, it will go to 15 million tons. And when we are talking of green hydrogen, only 5 million tons. If there are some obligations, some carbon credit scheme or carbon trading, which once it is rolled out, the government is already contemplating that there will be some obligation on some of the sectors to decarbonize. And those kind of activities will certainly push some of the steel industry or cement industry or the export, CBM being rolled out by Europe in next 2 years or so. That will certainly push some of the industries to definitely decarbonize, and hydrogen is one of the enabler for decarbonization. And that hydrogen has to be green hydrogen if they have to, call it decarbonization of their own products. So that is one thing. And if we have 15 million tons of hydrogen demand, and we are targeting only 5 million tons, I see that there should be the only issue is about the pricing. Because the refiners, as I said earlier also, and the fertilizer industry, they produce from natural gas, which costs about $1.5 a kg to them. Now, this differential, refiners, I think we had done some, I used to work for the Federation of Indian Petroleum Industry, and we had worked out that if the green hydrogen is to replace, say, about 15% or 20% in their hydrogen consumption, the price increase of the petroleum products would be a few paisa, 25, 30 paisa. And when you sell petrol at price of 100 rupees, if you increase the price by about 50 paisa, even that will not even be noticed by the buyers of the petroleum products, petrol or diesel or LPG, etc. So I think there is a great scope for some of these sectors like refineries, particularly. As I said, fertilizer is a dicey thing. But then the other sectors which will be growing, now the mobility sector, where we can create great demands. Actually, you know, I always say that although the EVs are picking up, but for heavy duty trucks, they are supposed to carry loads, cargo loads, not the battery loads. And if we have to use hydrogen, if we use in place of diesel or in those trucks, and create some of the national highways where hydrogen dispensing, which some of the projects have been awarded to Automotive Research Association. So there could be a large demand. Diesel can be replaced by hydrogen on the highways. Another issue which is important to create domestic demand is to create the infrastructure. One of the issue which I have been telling in various forums is that we are talking only about green hydrogen. I'm glad he raised about the blue hydrogen with CCUS and carbon, capture, and then rather than green, if we also allow blue hydrogen to be also used, which will average out the cost of green hydrogen to some extent. Hydrogen per se is colorless. We have given artificial colors, and that will help us in creating and rolling out the infrastructure fast. Because why people are not investing in infrastructure for hydrogen, which will create demand, of course, at the various demand centers, is that the cost of a green hydrogen is more. So if we allow any hydrogen to be sold, so that you create domestic market for hydrogen, and by the time the green hydrogen prices come down, as we contemplate in next 10 years or so, you will have infrastructure, so there will be people who would be willing to take hydrogen, because hydrogen will be required for decarbonization in any case. And most of the companies have announced their own plans to go to net zero, and they cannot go to net zero without hydrogen. So steel industry for DRI, etc. There are cement industry, which are hard to abate sectors. They have to go to hydrogen. So I think the demand will get created domestically also. Till such time, export opportunities which companies are exploring, it's fine. Then grid stabilization, as was mentioned, I think that's also important, where hydrogen, we were talking about, you also mentioned the same thing, that in Europe the solar power is more, and then grids are not willing to take. So hydrogen is, and in fact even for grid stabilization also, hydrogen is an enabler, because you have renewables which are cyclic. You have sometime winds, you have sometime solar, and whenever you have surplus, you can store it in the form of hydrogen and then have fuel cells, which will be even more efficient. I say that we should switch over from IC engines to fuel cells, which are twice energy efficient. If we convert our mobility sector fast to hydrogen fuel cells, overall energy demand will come down. Hydrogen will be much more efficient, so that we can, I think there are opportunities which need to be looked upon. And as I said, irrespective of the color, at this point of time, we should roll out the infrastructure, and just don't wait for the green hydrogen prices to come down and then say, okay, we have green hydrogen at lower cost, but there is no infrastructure for supply and distribution of hydrogen to various sectors. So I think these are some of the important points which I thought.
Very useful thoughts, Dr. Malhotra. Thank you for those. Rajat, I want to come to the export, market that we discuss. I want to get your perspectives on. We will not be the only potential supplier to some of the large demand centers, whether it is Japan or South Korea or some of the others. What are those safeguards that we need to ensure that India emerges as a export hub? So which are those other geographies where against who we are likely to compete, and we need to keep them in our front view? And what are some of those there are concerns around definition of green hydrogen, which are going around, that what actually is green hydrogen, what's the carbon footprint of it. So how do you see some of these challenges from a export potential perspective?
I think export is actually the biggest challenge we face in export. And when I say we face, I think as an industry we face from India is that our competition is not with green. If it is only about green, there is a reasonable chance India will be one of the most competitive territories to produce green hydrogen from, because we have reasonably competitive renewable energy prices. The challenge that I face and many of my brethren in the industry face is globally you have another form of clean hydrogen and derivative blue is what we spoke about. So what we really face is there are countries with abundant supply of oil and gas, and they have ability to temporarily reduce the prices of gas and then generate blue hydrogen, and they can literally throw out the green players out of the market or price them out. So I think that is number one challenge. I think why that challenge is important to be collectively addressed is, as an industry in India and globally, we need to realize that if the real aim of cleaning the world is there, it can happen only through green energy. Any other form of doing that is in one way or the other greenwashing, as is clearly known. Because if the solution was in capturing carbon, then I would go one step further and say, what's wrong with thermal power? Let's start capturing carbon dioxide in thermal power and perpetuate that. So the origin of where we started was thermal power. Thermal sources is not good enough in the long run. We need to have renewable zero carbon sources. So the first battle that we need to fight collectively as industry participants, as a country, is to ensure that in this race of getting into clean, we are not completely bypassed. People get into this blue bandwagon. Because one of the areas where I would have a slight disagreement is, in the long run, people say there will be green. I would say there is no long run if there is no short run large opportunities, right? Because we have seen this in sector after sector, that you need to go big right now and don't have any shortcut solutions of having something which fits the purpose temporarily and then drives out the real purpose of what we are doing. So that I think is very important. Secondly, I think is more cosmetic problems that we face is on harmonization of what is defined as green. I don't think the situation is that bad. Right now we have definitions of what is green in Europe, which has now become the gold standard. I think the time for arguing and quarreling has gone away. As developers, we just now need to know that this is the goalpost we need to adhere to, make products which are suiting to that requirement. And if there is any policy tweaking required with Government of India, we need to work with them. But we know this is what we need to produce. There is no point arguing, diluting those criteria. Because diluting those criteria would actually not be beneficial to us. A slightly stringent criteria actually helps companies in India because we are in a better position to meet those criteria. So I think we should just go by what has been agreed globally, align ourselves there, make our technical concepts accordingly, and be ready to supply what is required rather than quarreling about why is that required. So that is the second thing. Apart from them...
And is there, if I may ask, concerted effort which is going on, both at a country and at a global level, to make sure different people are not looking at different goalposts?
Yeah, so I think this is, to my understanding, ministries are seized of this matter because the lot of education has happened among the stakeholders and we understand what the issues are. At individual levels, I think there is a proper regulatory mechanism in Europe and in Japan where consultations go, the inputs go along. So I think that process is happening fine, and there is already something now which is defined. So it's not as if it's going to take in perpetuity to what is defined. So we need to just work with that and ensure what is the best product in the most cost-effective manner that we can come out with. So I think these are the number two challenges. I think India has got a great opportunities. I've scanned everything which is available in other countries, including in Australia, Chile, Middle East. No one comes close in terms of being able to deliver the electron at the cost and reliability that India can do because of the inherent cost structures which are there in so many countries. We need to seize this opportunity, do project at scale, have few success stories to start with, and I think there would be an autopilot mode the sector will be getting in towards the end of the decade.
Perfect. Very, very well said, Rajat. Thanks for that. Hiren, very quickly, I just want to get your perspectives on, the technology innovation one, in case, there's any incremental thing you think should be done, but also on financing. Do you see, there is adequate financing support from, multilateral green bond access? Do you face any challenges from financing your projects from that perspective?
Yeah, I mean, see, look, this point in time, looking at the size of the project and the capex involved, financing is one very, very important criteria for the success of the green hydrogen and green ammonia projects. And as we speak today, that any financial institute, the way they treat any green projects is like any other project. There is no special importance or the provision has been given to that. No finance company, commercial banks or the institutes are happy to give the debt, unless you have the long-term bankable green ammonia contract, and which is not been seen much. At ACME we signed probably the world's first long-term green ammonia contract, but there are not many, and unless those contracts will be signed, the finance will remain a challenge. Not only the finance, but at what rate also has one very important aspect. Of late we've seen that the cost of finance also has gone up. So from the both the perspective, it's not an easy way to get the finance, and that remains a challenge to overcome.
Thank you. Thank you, Hiren. Som, very quickly, since we are a little short on time, just to sum things up, what do you see will be the role of hydrogen in our energy mix very, very quickly to achieve the trifecta of security, affordability, sustainability?
So my quick snapshot on that will be, we need to bring in hydrogen production and consumption closer. That's point number one. Point number two is, we need to think about gas turbines, especially that are smaller in size, for this application, because the requirement is massive, right? The third thing is, and this is a space we have started working on, is transportation, especially when we are talking of cross-country, becomes really challenging with hydrogen. So, and that's where ammonia comes into the play. The question is transporting ammonia, cracking, and then using hydrogen make sense, or using ammonia in gas turbine make sense? I know thermal uses ammonia, and that's the space we have started working as GE Vernova with IHI to see whether our gas turbines can burn ammonia. So there are few innovations happening and few things we know are challenges. We need to find a way to go past the challenges so that realistically we can become greener as we go ahead in this. Color agnostic again, right? So I'll leave it there.
Perfect. Perfect. Thank you so much. I think it's been very engaging, very interesting discussion to pick your thoughts on very, point-specific opportunities and challenges that lie ahead of us. But I think few things are certain. Green hydrogen remains pivotal, is pivotal to our ambition of decarbonization as well as energy security. The exports opportunity is for us to seize. It ties up with the Make in India, with the job creation potential and the commerce potential, for the industry, for the participants in the industry in the country. The domestic demand remains promising. It may take a little bit of time to do that. Specific initiatives, whether it's mandates, as Dr. Malhotra mentioned, or looking at possibly broader applications across industrial, transportation, and storage. All of these could present exciting opportunities with the right, safeguards and de-risking on the demand side. But I think, and then very interesting points that Som mentioned around the green hydrogen and the ammonia opportunity as well. So with that, I would like to once again thank the panelists for sparing their time and sharing their thoughts. Very much appreciated, and to the audience for staying put and listening with intent. Thank you so much.
Nitin, and to the speakers, I just wanted to check, would you be taking any audience questions?
Sure, we are happy to. Any questions
Yes,
from
please
the audience
raise your
to
hand, identify yourself and ask your question to the speakers in case you have any questions.
I think it's a great opportunity. We have leaders, experts, from the industry. So questions to any of them, us is welcome.
If you have a question, just raise your hand and you can pose your question to the speakers. Identify yourself.
या कोई माइक मांग रहा होगा तो देखो
I think if there are none, we'll call it a close.
Right. There is one question there. If you can, the mic can be taken to the table at the far end.
My question is for Mr. Shom. Regarding the firing of hydrogen directly in the gas turbine, apart from the volume, which you said for this thing, which I fully agree, have you any data in terms of long-term life degradation using hydrogen in this thing, and how is it going to push up the cost, and what are the remedies? Right.
No, thank you for the question. I didn't get your name though, but thank you for the question.
I'm Ujjwal Bhattacharya. I was earlier Director of Projects of NTPC. Your bosses may be knowing me.
Okay. No, thank you for the question. So the way I would take your question is, hydrogen is a difficult fuel. So when you burn hydrogen, you got to play with the controls to make sure the flame is far away from the hardware, because it tends to come back. As the flame tends to come back, it wears the hardware faster. Now, so definitely natural gas versus hydrogen, you have to have a different control curve, different controls, philosophy in place in order to make that happen. That's number one. Number two is, we have been burning hydrogen on oil and gas industry quite a bit. So for example, Reliance, I know, we burn certain version of syngas in there, but we also have plants in Korea where small machines, 6Bs, we are burning about 84 to 90% hydrogen depending on the refinery production. What we are doing is, we are taking those hardware, doing tear down on the hardware to see, do we have the right models to say what the hardware life prediction should be? Because one is, you can control the flame, we have maintenance factors on it, but then there are things that hydrogen uniquely does. It does the penetration on the metals, the leakage rates, which are different when you have different curvatures on the pipe, different stress levels on the pipe. When there are different blends on hydrogen versus pure hydrogen, the behaviors are slightly different. So we do analyze those hardware to learn and then turn around and say, IPP machines, bigger machines, this is what we got to do in order to protect the hardware. Some cases we have to add additional layers on the hardware. Right? So we have learned quite a bit, and that has given us the capability to go up to 100% on certain frames, especially which are standard combustors. DLN combustors, dry Lonox combustors, we are lower, but with the 7HA, 9HA fleet, we can go pretty high on them as well. 9HA fleet, we can do 50% right away. So.
I think we have another question, if you can take the mic.
Yeah, good morning. I am Anjan Sinha, Director Intertech. Yeah, this was just an extension to that earlier question. Means I don't find data when I look for this data. Actually, we do a lot of this stuff, damage modeling, and like we can very precisely calculate the fatigue creep cycles, corrosion fatigue, provided the data is there. And we work with utilities in US and Australia and across the globe. But I couldn't find any data on this. So what period of data you have?
So first of all, thank you for the question again. The first gas turbine we started operating on hydrogen, certain versions of hydrogen, was 1977. So it's quite a bit of time that we have started using hydrogen. We do have data footprints across the board. What I will do is, we can touch base. I can let you know what kind of data you would need. My colleague, Jay, will be doing a session tomorrow, and he will try to go deeper into the technology. If you are there, that'll be amazing. We can answer some of your queries too. But get in touch with me and Jay, right? We'll try to get as much details as you want, right?
Sure. Thank you. Thank you.
Any more questions? Yeah, I think, any more questions?
I think with that, we'll call it a wrap. Thank you so much, Som, for taking the questions and the audience for asking those. And thanks everyone, Som, Hiren, Rajat, Dr. Malhotra, for sharing the perspectives of the last 1 hour or so. I really appreciate that.
Please give a round of applause to all our speakers on stage. Thank you so much for sharing your thoughts with everyone. I will request Nitin Khanna to please present our speakers with mementos. We are grateful to them for coming here. I request you to please present a memento to Dr. R.K. Malhotra, President, Hydrogen Association of India. Thank you, Dr. Malhotra, for joining in this panel and sharing your views with the audience on how the infrastructure needs to come up before the demand does, else we'll be waiting too long. Memento for Mr. Rajat Seksaria of Adani New Industries. A memento for Shri Hiren Mehta, Chief Commercial Officer, Acme Group. And a memento for Shri Som Shantanu of GE Vernova. I would request Elizabeth Bruce, Portfolio Director, Energy and General Manager, the Netherlands Cladron Events, to please present Nitin Khanna with a memento. Thank you so much, Nitin, for starting this discussion. Thank you. I request all of you to please gather for a group photograph. A quick group photograph. Please give a round of applause to our speakers. Thank you so much.